feedback if we may share then the video recorded with the Lisbon Council and maybe put them on a YouTube channel in order to have them more well, accessible. I don't know if Marcello is back, but then we can ask him later. Okay, so the agenda will keep going with Frost. Both Martina and Bea will present what the Frost open source is, and then we will have again Luca in talking a little bit more in details about the extensions or the extension already anticipated for SensorThings, namely SensorThings STI Plus, that is related to also to citizen science, but could be interesting in EDIAQI project as well as in other projects. And then we will conclude, I conclude with a brief presentation about the INSPIRE directive, because air quality monitoring station, in particular those for outdoor, are already part of one of the 34 themes addressed by the INSPIRE directive. Okay, I leave the floor to Martina.
Okay. Here you can see an
Martina,
overview.
You need to share the screen.
Yes. Here you can see an overview of open source SensorThings API implementation from Wikipedia. And there are those, but we will focus on Frost server, that is an open source implementation of the Fraunhofer Institute. And the acronym, it means Fraunhofer Open Source SensorThings API Server, but is also intended for fresh and available data. And we choose this one because is the most complete and compliant to the standard, and is also recommended by the European Commission, and is as a good practice. And the Frost server could be deployed in a Tomcat application server, and it need also Postgres SQL and PostGIS extension, and is also available as Docker image. Only going fast, short, with Postgres SQL, that I think it could be connect. Postgres SQL is an open source relational database, and the PostGIS is an extension to deal with the geographic data. So it add to the PostgreSDB feature to for spatial data storage, for indexing, and also spatial function, and it could be you could connect to PostGIS data also from QGIS and from other server. These are the components requested by Frost server. Timescale DB is already an optional component and is another extension of Postgres to handle time series data. Time series data are data where data over the time. So, for example, when you get some measurement, maybe for temperature, you can have more measure in the time. So you are collecting time series data, and this data could be archived in a without compression using timescale DB. And there are hypertable used to handle this data in a fast way. So is not a mandatory component, but is best to install. And then for other optional component, I leave the floor to Beatrice.
Thank you. Just a sec. Okay. Okay, so as Martina was saying, since now we have talked about the standard, the SensorThings standard, and then now we are talking about the Frost implementation, which is one option of implementing it, and then we have some components that are required to implement the Frost. But there are others that are not required, but still we use them a lot because we think that they are really useful on our the job that we have to do. They really help us. One of these is Apache NiFi, which is a software that is implemented by Apache Software Foundation. What it does, it basically automates the flow of data between systems. So it's able to, it follows the ETL concept. So it extracts data, for instance, from APIs. It transforms it, and this is the part where we use it a lot because we need to get the data and transform them so that they are compliant to the standard. And then finally, we load them in another system, the system we need to put the data, which is our Frost structure. As you can see, it's pretty easy to use as like the user interface is the one you see, and it's made of blocks, and it's a flow-based design. And the second component that we highly suggest you to use is GeoServer. GeoServer is an open source server. It's really useful because it allows to use open standards to create maps and share data. It's also very good for interoperability because it publishes data from all the major spatial data sources, and it also is able to display data from Google Maps, Google Earth, and all the major mapping applications. And I know that these are a lot of components, but just to make you an example of how we use them, I will show you one of our use cases, which here is the Airbrake index. So Airbrake is, I think it was mentioned before many times, it was a project that we made. And in this project, which is of course about air quality, we created this index. I just show you for a sec the final version of the index, because this is the final representation, and then I will explain to you how we got there. So this is the index. As you can see, there are many visualizations.
No, Beatrice, sorry. We are still watching at the slide.
Sorry, yeah.
Because you probably shared only the PowerPoint.
Right, thank you. Yeah, sorry. So this is the index. The aim was to give an overview of the air quality in the city of Ferrara, which was our pilot. And we have many visualizations. So here we have like the pollution that is fluctuating on Ferrara. And then we have like the different stations. We have like a graph to show how the time series of observed properties, and then we have the 5 different substances. This is the output, but how did we get there? These are the steps. The first step is that we are not the one who collect the data. So Lab Service Analytica collects the data and they make them available through their property API. So what we have to do is to get that data from, and we use NiFi, as I was saying, and then we make them compliant to the SensorThings API standard. So we transform the data and then we put them in the server of the municipality of Ferrara. Once they are there, we know that they are compliant, so we can use them. And we use them to create our hourly index. So the index gives us information every hour about the 5 substances, pollution substances. And then at this point, we use GeoServer so that the index can be published as WFS or WMS. And then we made 2 things. So the first one is that we can display that files on a map using any compliant client. And the second thing is that we publish the aggregated data as a layer on the open data portal of the municipality of Ferrara. And also, thanks to all this work, we can have the index that I showed you before. Yeah, so that's all from my side. Thank you.
Yeah, it is. I think that it is noteworthy also mentioning the fact that this data, the index, as well as the single parameters, are also made available in the open data portal of the municipality. So all data behind are automatically provided as data available within this open data portal. I'm pasting here the link where you can download data about air quality. Of course, we are talking about outdoor air quality data. So here is the link, dati.comune.fe.it, and the query is so the catalog, the open data portal is queried by using the keyword area, air, and you can see the single 5 parameters that are used for creating the index, and also the two data sets that are the average air brake index. So it is referred to the whole urban area, and also the index calculated at a single station level. So this the data available in the portal are the same with the same WFS endpoints, also used by the widget, the JavaScript widget that Beatrice showed. So in the dashboard, che aria tira, the elements, the graphical interactive elements. So the first widget containing the floating particles, the top of the page, or the second widget containing the interactive map together with the browsable diagram. And then the third widget that is showing in simple bars the normalized values of the 5 single parameters. These data behind are coming from the same WFS endpoints that you have available in the Open Data Portal. So a unique way to provide data about the index that is used for different goals, for different targets. On one end, the WFS endpoints for the index are used for downloading data, from the Open Data Portal. And when we say open data, we mean that these data are freely and publicly available with the open license. In this case, Creative Commons by attribution license. And at the same time, the second goal is to have this data used by widgets like the ones that we included in the airbrake.net Chiariatira webpage. So to show to interested citizens the status of the air quality at a frequency of every hour. Do you have any questions on this? I think that this is somehow also related to task 3.2 of EDIAQI project. So I don't know if someone from colleagues connected from Tropos or other partners of EDIAQI project are having any questions or comments. If not, we may change again the speaker with Luca, presenting some further details about the extension. So the extension already mentioned before during the first slot this morning. The extension is called STI Plus. It was candidated by OGC as a possible extension of the standard itself at the beginning of this year. So it is not yet fully adopted by OGC, but in the following months, by the end of this year, it should be adopted. So there is already an implementation, an open source implementation of this extension, and it could be interesting for some projects like EDIAQI as well as usage. Please, Luca.
Yes, thank you, Pier Giorgio, and hello again. As promised, we will be talking a little bit more about STA Plus. Of course, the STA Plus standard is an extension of the SensorThings API, so it is meant to be backwards compatible with an already established implementation of STA. And what was the need to create this extension? Well, according to the creators of the STA standard itself, that was the basic standard, the one we have been describing up to now, was created with the use case, with this use case in mind, of that of a single authority that provides sensor reading to customers. So there was no need to distinguish data streams and things and sensor in groups. In the case we implemented the majority of cases, that is, we implement an STA service for a local administration. We are actually using it already in a different way. It's not the data provider that has it, that should be the goal in the end. Data should be provided by the providers via by SDA compliant endpoints, but up to now that's not the case. So the SDA implementation is present at the user end of the data flow. So local administration that require to collect data about from sensor in their territory have installed, and I'm talking about cities where we actually have done this in Italy, have installed an implementation of SDA to collect data coming from different types of sensors and different types of providers. So that's why even with the basic version, of SDA, I mean, with the standard we have been describing up to now, we are out of the use case that was meant as the primary, the one of the authority providing the data, because we are collecting data from more origins, and the local administration needs to group them. And up to now, this grouping requirement was implemented by using that the properties element that is present in every entity that allows to add information in addition to the elements that are to the attributes that are present by the standard for each entity, and we use that basically to label each data stream with a name that is connected with the data provider, and in that way we can group data streams in relation to the provider. But this extension, SDA Plus, offers a more structured solution to this problem of grouping. And as I was saying, it is meant to answer to the needs of the citizen science domain. But in doing that, it helps also this other use case I was mentioning. So what's new in SDA Plus? Well, SDA Plus is designed to support a model where observations are owned by different users. So it is part of the model now, the fact that there are different users, different data creators, let's say, and also there is the possibility to specify a license for the observations, for the data related to observation, and different license related to different types of users and different data streams. Moreover, it is possible to put different observation in relation one to the other, different data streams, and also to group observation and to group data streams in different groupings. So let's say how that is performed, again, by having a look at the model. Before actually doing that, I just wanted to point out to where you can access to the current to the documentation of the current in progress version of the extension, and that is the link. Okay, so we will zoom in, don't worry. This was just to provide a general overview. The let's say pink boxes, the one with no text inside them, are the elements of the original structure, of the basic structure of the SensorThings API model. The other boxes, the gray ones with the attributes well described, are the ones that are added by the SDA Plus extension. And we have, just mentioning the titles, party, which means user, so owner of the data. There can be different parties that collect data, so different owners. Then there's an entity called project, that Oh, sorry, before actually, no, well, let's just mention the title. So that there is an entity called project that allows to group together observations and data streams related to the same project. And that's actually, that could be a solution to the problem I was mentioning, to the use case I was mentioning of the local administration that needs to group data under the same label, under different label actually. Then there's the entity that allows for the description of licenses. Then there's an additional entity again related to groupings, so groupings not related to projects. And then there's an entity with the generic name of relation that allows to put observation of different data streams in relation one to the other. Maybe observation of the same phenomenon at the same location, but performed by two different users with two different sensors. And thinking of the domain and use cases of citizen science, that could well be the case. The same, I'm always thinking about temperature sensor as examples. I'm sorry for that, but you could have citizen temperature sensors that are measuring the same temperature on the same street in the same day, and it would be useful to put them in relation. They would be part of two different data streams: the data stream of the sensor A owned by the person A, and the data stream of the sensor B owned by the person B. They could have a location, that two different locations that are close one to the other, because they could have been configured by each one by each user by putting a point on a map that's on the same road, but it's not in exact same position. So you cannot use location as a way to realize the fact that they are actually measuring the same feature of interest. But thanks to relation, you could put directly in relation the observation, the couples of observation collected by those two sensors. So trying to zoom in a little, I just want to see how the new entities are related to the old ones, and maybe even read a little bit in details the element, the attributes of each element, of each entity. I'm sorry. How can we do this? Well, maybe to see the relations, it's better to move back to this. You can see that party is related to project, but is also related to groups. So a party, meaning a user, a owner, can own a project that then groups, we shall see observation, or can own a group, or actually can own either projects or groups. And party can be also directly connected to data streams, and also things can be connected to parties. So you can explicitly say that a thing is owned by a party. While groups can be groups of observations or groups of licenses. And projects instead can group together data streams. You have to think about this as a model that wants to be as open as possible, so as to fit as many situations possible. So that's why it could look as if it is offering too many options of grouping observations in different way. You can create a group of single observation, but you can create a group of data streams. But through the entity project, then you can group together data streams. So you basically are offered a way to a tool that can be adapted to hopefully also your specific situation. And the last thing that I want to point out is the one I was talking about before. We can see maybe a zoom here, the fact that you can put in direct relation two different observations from two different data streams exactly for the same reason I was describing before. Finally, as Piergiorgio has already mentioned, even if this is not yet an officially recognized standard, is under discussion, but the prospects are I mean, the future of it seems quite well directed towards acceptance. And there's already an implementation of this extension, and that's again from the Fraunhofer Institute, and so it's an extension, it's an implementation that extends the Frost implementation of the basic standard. So it could be plugged in to the implementation of the basic standard, and that means that it's if you start from if you adopt Frost as a solution, then you will be able also to test and try and experiment with the STA Plus implementation. And that is all. So I give back the floor to Piergiorgio.
Okay. Here. Are there any questions from the audience? Otherwise, we can conclude with the final presentation that is related to a sort of ancillary thing that is the Inspire directive. Since we have been talking about interoperability, I think that it is important that all of us are somehow aligned with the basic principles and very, very basic knowledge about what European Inspire directive is. So I take the floor. Let me share my screen again. Okay, can you see it?
Yes.
Okay, thanks. So after this final set of slides, we would like to have a sort of wrap up and round table from all of you in order to also to let us understanding if we we succeeded to address the aim of making our own data, in particular dynamic data from sensors in the pilot areas of EDIAQI project, but also beyond the EDIAQI project, to be fully interoperable through standards like the ones that we mentioned. So I start from the one of the first slides that we saw at the beginning of this morning. In this slide, Inspire was explicitly mentioned here in when referring to buildings data specification. We will have some slides focus on this, but it is important that we fully understand that a lot of guidelines, technical guidelines, but also norms in terms of Commission regulation, so regulations coming from the European Commissions are already there. That facilitate us to avoid to reinvent the wheel. And I think that having somehow data aligned or close to what Inspire directive is suggesting, is requiring, could be a real added value. So before talking in particular about the Inspire, I think that it is important to start with this, with the concept of infrastructures for information, in particular for spatial information. So for infrastructures for data having also a spatial component. also known as spatial data infrastructures, and defined in the literature in different papers and works. In general, all definitions are focused on components of these infrastructures, not only data, but also policies, standards, requirements, the need of having such data infrastructure in continuous evolution, with a direct linkage between data producer on one end and data user on the other, with the aim of sharing and interchanging data, and with a particular also focus on organizational aspects. At the beginning of 2000, and in particular in 2004, there was one of the first cookbooks, one of the first white papers was published on the web, edited by this guy, Doug Nebert, summarizing the concepts of, in that case, spatial data infrastructure. But we put spatial in brackets because the same concepts also apply to data that are not explicitly having a spatial dimension. So a data infrastructure usually hosts geographic data not in a centralized way, but by connecting different servers, different nodes of the infrastructure, for discovering, for visualizing, for evaluating such data, based and including organizational agreements. This is important. So it is the somehow the hidden part of what a data infrastructure is. And as highlighted here, connecting applications to data. So the aim is to have something that we tried to show you this morning when showcasing, for instance, a QGIS desktop application or Excel spreadsheet connecting to data sets coming from remote servers, like the one that we used in the examples. And of course, at the bottom layer, or at more correctly as a skeleton, we need to rely on appropriate standards and policies. Another useful reference regarding spatial data infrastructure is this one coming from Q11 within the a European project called EU4Geo. And all of these definitions are deeply and heavily focusing on interoperability. That is somehow the core of that infrastructure, and it is, as a term, is well defined also in ISO EDIAQI standards, like the one mentioned here. So the ability of two or more systems to communicate and to cooperate each other, sharing data through the adoption and communication protocols and standard formats. That is exactly what we tried to showcase you this morning. Here there is a very brief video that is available on the Inspire website of the European Commission. I don't know if
We cannot hear it, Pier Giorgio.
Oh, sorry. I thought it was, but anyway, this is available on the Inspire website, and we will add here in this slide the link to this YouTube video. So it is very, very simple to explain the need for making data that are referenced to the environment, also including air quality available in an interoperable way. So Inspire is a directive, is a European directive, and as you all know, a directive is an act, is a legislative act that sets goals and principles that have to be applied to all member states. But to be somehow adopted, each member states in the European Union has to apply a national legislation receiving and implementing such principle. And in this web page of the European Union, there is a practical example, not dealing with air quality data or Inspire directive, but dealing with single-use plastics directive that sets some principles that have to be considered by all member states by adopting specific norms and rules within their own countries. And Inspire is a European directive that defines these common principles. The first one, the very first one, is that data should be collected only once and kept where they can be maintained at the most efficient level. Data have to be combined in a seamless way, so independently from the sources. In particular, when considering the whole European context, it is important to combine data coming from different countries, from different areas of the European Union. And it should be possible to share information and data collected at different scales and different levels. And these data have to be used in particular by public bodies, by public authorities, in order to improve their own policies related to environment or to other domains. The directive is published here. It was approved in 2007, so many years ago. And again, in this directive, in this document, we can find only somehow the principles, but they are important also because they are referring to many topics, many domains and categories that are related to environment. In particular, the highlighted ones, so environmental monitoring facilities as well as atmospheric conditions, are very, very strictly related to projects like EDIAQI, but also air brake or usage, since they are referring to practical things like data collected through air quality monitoring stations or atmospheric and weather monitoring stations. So data collected through this type of networks, this type of facilities, should be made available by public bodies as well as by private entities like utilities working on public services in a manner and in a way that facilitate the interoperability of such data, not only in terms of formats and coding, but also in terms of services for accessing this data. And when saying services, again, this concept is well defined in the concept of service is well defined in the directive itself. There is a specific article number 11, that provides a list of different types of services for instance, viewing or making downloadable, making accessible data. So this article is very important for all member states and for all public authorities in the different member states, because it defines how at the single member states data referring to the topics listed here in these 3 annexes should be made available to other parties. So not only thinking in terms of web portals for humans, but also in terms of pieces of software based on standard protocols like APIs or like the ones that we mentioned at the beginning of this session, WMS or WFS, for making this data available to whatever type of software clients. Okay, so we are starting to highlight the fact that Inspire is not only a directive, because apart from the directive itself that is mentioning principle, that is setting out principles, we have a list of Commission regulations, and Commission regulations that are listed here are automatically binding laws applied at a single member state. So while the directives have to be, let's say, transposed by legislative acts in single member states, the regulations are automatically laws for every single member state in Europe. Regulations are already translated by the European Commission, by the translation service of the European Commission, into the 22 or 23 official languages of the European Union. So that means that in the website of the European Union, in this this link, you may find, for instance, the regulation number 1089 that is related to data, that is available in all over the languages, the official languages of the European Union member states. The first important regulation that that we may consider here is the one regarding data. Let me skip back for a while here. When talking about data, we are talking about this comprehensive list of topics, of data themes that are also including data related to environmental monitoring facilities, atmospheric conditions, but also here buildings. And this is important because in the case of EDIAQI project, we are considering indoor air quality with data to be collected inside of pilot buildings. So some elements, some attributes, some properties of pilot buildings could be already there, could be already be made available by Inspire in terms of regulations, but also in terms of technical guidelines. For instance, in the case of the regulation mentioned before, 1089, the regulation itself already includes a list of common properties, of common attributes that have to be applied to all types of data. So in this case, for instance, when considering also environmental monitoring facilities or buildings, or they have to be applied to specific data themes. So, for instance, all data sets falling into the Inspire directive shall contain identifiers to be expressed with these attributes, so a local space and a version of the identifier. And when considering buildings, there are specific properties, specific attributes that are already contained, that are already defined within the regulation. That means that they have to be implemented when sharing data about buildings. And for instance, here we see some attributes. So the name of the attributes, the physical name of the attributes is always in English. So the physical name of the property. While here we see the translation in Italian. We use the translation, the Italian version, just to showcase that the same regulation is available also in Italian language, so in one of the official languages of the European Union member states. And in here we have a list, a first list of attributes to be considered when sharing data about buildings. So the name of the building, its date of construction, demolition or renovation, of course, if data are available, and also then the nature of the building, so its characteristics, its use or its usages, number of dwellings, number of building units. This is also reflecting to the fact that each building can be split into different parts. So we may have within the data set to be provided for sharing data about buildings, not only the buildings as a whole, but the single parts composing the buildings. And these properties could be applied to the different levels, so to the whole building or to single parts. The height of the object, so of the building, and some properties, some attributes are containing a reference to a specific list of codes, a specific list of values. For instance, the property, the attribute current use that was mentioned here. So here the attribute current use is having a data type corresponding to a code list already called the current use, that is having a list of already defined possible codes and values. So residential, that can then be more detailed in individual residence, collective residence, two dwellings, and so on. And all this information is not only provided within documents, verbose documents that can be accessed and downloaded by the European Union website, but can be also accessed in the web accessible registry made available by the Joint Research Center at the inspire.ec.europa.eu. And the same, for instance, the same list of possible values for expressing the use of buildings is available online in the different languages. So here we see the Italian version, and these terms are not only listed but are also explained in terms of meaning. This is important because what Inspire tried to do, and what Inspire Directive is trying to do, is not only to provide mechanisms for making data interoperable from a mere technical point of view, but also from a more semantical point of view. By using these terms, this value, we are already sure that the meaning of specific values like residential building, like industrial building, or ancillary building is properly defined with a very clear and understandable meaning. Apart from regulation 1089 that is referred to data, we have another important regulation, that is this one, that was then amended and updated. that is focused on services, so on what the Inspire directive is calling network services, so mechanisms, protocols for making data accessible and interoperable based on standards like the ones that we mentioned so far this morning. The third level of Inspire-related documents are represented by technical guidelines. So while the directive sets the principles and Commission regulations defines what is legally binding for each member states, for each public bodies, public authorities, and also private organizations dealing with public services, the technical guidelines provide not legally binding information, and so define how member states and how organizations within member states might implement the rules defined and the principle defined above. And for instance, in the Inspire website, we can find the data models for all the 34 data themes, so then including also environmental monitoring facilities and atmospheric conditions, as well as buildings. And these models are tightly coupled with the ISO standards. The ISO package that are used is the ISO 19100 package of standards that are focused on geographical data. And in this case, all the data models behind Inspire data themes are based on a conceptualization of the real world, and then translated into a conceptual model first, and then into physical implementation of these models. I skip details. You will have, if you want to have an in-depth exploration on your own, you will have these slides available, and you may look at them. So the data models of all themes addressed by Inspire are usually presented like this, with the UML class diagrams, like the ones that Luca, Beatrice, and Martina showed before when referring also to SensorThings. So class diagrams that are depicting the models, the data models of each class, the relationships and connections with other classes, and the properties of each class in terms of attributes and cardinalities. Of course, the data models are also described in a more verbose way within a set of documents like this one, providing a full list of examples, and they can be also explored in a more interactive way in this way. And for instance, in the case of buildings data themes, again, as mentioned within the document describing the data model of the buildings data themes, there are clear and explicit reference to air pollution and air quality directive. So buildings data are important within the Inspire context, so at the European level, for many things, for many goals. And some goals are also considering other directives like the one mentioned here, not only air quality directive, but the directive dealing with the energy performance of building, the soil directive, and so on. And these data models, again, looking at the specific example of data model dealing with buildings, are based on existing standards. So again, also in Inspire, the working groups that drafted and then published all these technical guidelines didn't reinvent the wheel. They started not from scratch, but by leveraging on existing standards like the one mentioned at the bottom of this slide. For instance, for the data theme buildings, a standard defined by the Open Geospatial Consortium was already existing. It is called CityGML. So the buildings data model of the of Inspire is based on this standard. Okay, and going back to technical guidelines and sorry, going back to services and concluding this presentation. When talking about technical guidelines, Inspire is already suggesting and providing technical documents for implementing services for viewing or for accessing data based on OGC standards like the one mentioned at the beginning of this morning session. For instance, WMS for viewing and WFS for accessing geographical data. But recently, in the last years, thanks also to European projects and to the involvement of people mentioned here, Hilke van der Schaft in particular and Katie Schleid, the Inspire team led by the Joint Research Center of the European Commission tried to stress the idea of linking together Inspire network services for downloading. Downloading means accessing, so they are synonymous on one side, and SensorThings on the other. So in this website, on this GitHub repository that is managed by the maintenance and implementation framework of Inspire, we already have some useful information and useful materials related to the possible extension of Inspire towards the Internet of Things through the standard that we have been working on during this session, that is SensorThings. And in this GitHub, there is a reference to this publication that is available here. And there is also a reference to this simple Excel spreadsheet that is useful for matching together the concepts already expressed by the GML implementation application schema for environmental and monitoring facility that also include, I remember, air quality stations expressed in using a GML standard on one side, and the concepts behind the SensorThings API that are listed here in column C, in columns C and D's. Okay, this is was the final presentation for today. I do think that there may be many questions or comments or doubts or just curiosities. So we would like to leave the floor to you all, and do not hesitate to open your microphone or to type whatever you need to better understand or to further explore in the chat. So okay, my screen is not shared anymore. to break the ice again, together with Beatrice in particular, and also Martina and Luca, we prepared some questions that we would like to ask to you. But again, please feel free to break the ice. For instance, yeah, I see Khalil raised his hand. Your microphone is muted, Khalil. So you have to switch on your microphone if you want to.
Can you hear me?
Yes.
Okay, so thank you for your presentation, and I have a question for Beatrice. My question is about Apache NiFi. So what are some key features and capabilities of Apache NiFi that makes it a powerful data integration and processing tool? Because as I saw in your presentation that it's connected to GeoServer, and it needs with the part of platform which having this same boxing. I have a big question that how it's powerful data integration and processing tool. Thank you.
Thank you for your question. I don't know, maybe Luca wants to take this one since he's like the NiFi expert.
Okay. No problem. Well then, the power in the tool stands in the fact that it's highly customizable. So and also the way you create the flows, the procedures to actually elaborate data, because you basically create them graphically. You have a white paper, like as if it was a white piece of paper, and you put together, you draw the flow by choosing in a list of processors that does each of them does one different, very specific operation. One processor is able to unzip a file, another processor is able to make a query on a database, another processor is able to read a file from the file system. Okay, so you have to decide which small operation compose your flow. You have to connect them. You have to configure each processor so that it does exactly what you want. And so it's easy to transform what you have in mind into something, to an implementation of it, and also to test it, because you can follow the flow of data from one processor to the other and see what's changed and if it's changed in the way you were planning it to change. And it's powerful because it's easy, and with this approach allows you to create very complex processes. I don't know if, and it's open source, so you can contribute if something is missing. If there's a processor that you need that's not available, you can create it and make it available to the community. Of course, there's already processors that are generic. They can basically execute scripts in many different programming languages, so you already are able to create your own without having to change the code of NiFi, but you could change the code of NiFi to expand it because it's an open source project. So those are all characteristics that makes it powerful and desirable to be to use as a tool. I hope that answers your question.
Yes, thank you.
You're welcome.
Yeah, of course. Today we just had a very small anticipation of what Frost and other components like Apache NiFi or GeoServer are. The idea is to go in details in the sessions that we will organize in July, on July 21st. So looking in details on an example of implementation of Frost coupled with NiFi and GeoServer, like the ones that we are using deployed on both our own server in DataNext, but also in the reality in the case of the municipality of Ferrara. So to start breaking the ice, I have a question, a specific but ancillary question to Marcello Verona from the Lisbon Council. Is a sort of logistic question, Marcello. We would like, of course, to provide copies of slides that we presented this morning to be made available and shared, which is the most convenient and easy way to make them available. So can we share with you, and then you will put somewhere in the channels of the EDIAQI project?
Yes, it's fine. Do you think we need just an internal use, or are you thinking also a publication on the website?
I think that, well, since we agreed on opening this session, but also the other ones, also to people that are external, that are outside the boundary of EDIAQI project, I think that they may be useful also for external users. Yeah, so they may be made available. Okay.
Yes.
Okay.
We will publish new section materials or outcomes or something like this, and we will put the slides in the website. So,
and we will, as soon as they will be available, we will also share the links to the videos recorded.
Yeah. Okay.
Okay. Thanks. I don't know if you have any specific question related to the contents of today's session.
Not from my side.
Okay. So maybe, Alice raised her hands, please.
Yes. So as you know, I'm from Tropos, and we are going to be dealing with these things also in task 3.2.
Yeah.
To be honest, it's a little bit overwhelming since this is a task for Lina and she is more adept to this. So I think my question is about how will this interact with the other standardized way that we are trying to adapt in terms of reporting the air pollution data. So for example, we are part of the IDEAL cluster, and I believe there is also a way there of submitting the data. And then, so this would be a way that the data providers would have to learn. But at the same time, if you want to proceed with interoperability, let me know if I'm wrong, that the Inspire has also their own guidelines on how to report information. Did I understand that correctly? So then would the data providers be doing two types of data format to abide by the EU laws?
Yeah, there isn't, as far as we know, there isn't a unique comprehensive way to make data about air quality, but also about other topics in a unique encoding, a unique format. So there may be different standards, hopefully linked each other. But when considering the need for making dynamic data coming from sensors, so sourced by sensor, fully interoperable, as suggested from the beginning of the EDIAQI project, SensorThings that is also suggested by and encouraged by the Inspire pool of people. So the people working on the Inspire directive is a stable and structured way to make these data available in an interoperable way. I think that we need, within EDIAQI, we need to better explore the content that is required by other standards, like the ones that you were mentioning when considering reporting, and so yeah, we need to cross-check how to make matchable these standards together.
Okay, thank you. How do I put my hand down?
Are there any other hands or voices? We prepared some questions to you. A first set to be replied possibly in the following couple of minutes. And Beatrice, could you please show
Yes.
the slides with links? So we wanted to collect
Just,
some.
sorry,
See,
George,
yes.
I think Khalil has another question. No, because
Sorry,
okay.
yeah, I didn't see it.
I'm sorry for interrupting. So my second question, which is if there is information for the more context or clarification about ESTA Plus, which we is speaking about, as I record in the presentation, the name is Luca.
Luca? Yeah.
Yes. Thank you. So if you could please provide more context or clarification about ESTA Plus.
Yes, it is an extension of the standard STA. So it is something that adds some entities, some elements to the basic models, and that and it was created to support the use cases related to citizen science, and it does so by creating new entities like group to group observations together, or party to establish an information of ownership for data, or even project that that allows to mark, to put in relation observation and data streams to a project, and finally allows to put in relation observation from two different data streams. And there is already an implementation available, even if this extension to the standard is not yet confirmed as a standard by itself.
I understand. Thank you.
You're welcome.
Okay, so I can go on with the questions.
Thanks.
Yeah. So what we have thought, just let me share one sec. Okay. So we thought about asking you some questions with Mentimeter, which is this like tool to and it's an interactive tool to answer questions. And now I will explain you how to do it. So what I want to say is that these questions are not like a test for you. It's mainly for us to understand if we were clear and if we deliver the content in the correct way. So I mean, it's okay if you don't answer correctly. They are just 5 questions. So the instructions are this one. You just have to go to menti.com, as it says up here, and it will ask you to insert a code, which is this 8 numbers code.
So maybe I type it here in the chat. So to copy paste 66236245.
You can do it either with your mobile or I think also with a personal computer. And as you answer, if everything goes correctly, the answers should appear here. Oh yeah, okay, great. Yeah, maybe like now the answers are a bit biased.
So
just
so we don't. So data people should not reply. Yeah, should not answer. Otherwise, yeah.
Okay, just a few seconds more. And let me know like if you have any issue, maybe you can write it on the chat. Okay, I think I can reveal the correct answer. And it's true. And this was explained by Martina. I don't know if we want to give some context or just go on. Here, Giorgio. Like,
yes, please. Yeah.
Okay, so I go on or?
Yeah, sure.
Okay.
So
next question. Okay, so now if I put start Menti, it should appear on the same screen, this question. Okay, and you can put more than one answer here. Maybe we could have put some ambient music here to entertain.
Yeah, for next time, yeah, we can have a playlist.
Yeah, exactly.
Oh, okay.
EDIAQI playlist.
Yes.
Okay, so next, yeah, I think you can keep answering, but yeah, we can show the correct answers. So quite good, I have to say. We don't have measurement and time series in the data model, even if like they are related expression, related words. Next one. So one of these two components is required for the first implementation. The other one is not required, but can be added. Okay. I think I can show it, and it's correct, of course. So we only need a database, but we can add GeoServer if we want. Next one, it's about the STA plus extension. What was it developed for? Okay, you are just too good. Okay, and the last one, what is the entity party used for in STA plus extension? Okay, so very well. I think we did quite good. And so the last thing we ask you to do is to fill this Google form. It's really easy to do. There are like 4 questions, and it's just because so you can give us suggestions for the next session. Because I mean, this is trial and error, so we are trying to experiment a new way of training. And so let us know if you have any suggestions, and we will for sure keep them in mind for the next session.
Yeah,
I
maybe
think maybe we can
can
pass in the chat the link too.
Yes, please.
Can someone do it?
Yes, yeah. I can do it right now, and then we can. Okay, copy.
I don't know if we want to leave like 2 minutes to fill it now, or you do
so
it.
this Google form is not to be filled necessarily now. It is for next session. So if during this week you could reply to these few questions, is to balance our next session for July 21st. So we asked some hints, some comments and suggestions to you about the duration of the session, the clarity of slides, and any other suggestions that you have in mind. So I think that we may interrupt I interrupt now the recording of the video.